Okay, let's do our atom inventory. On this side there are 2 irons, there are a total of 4 oxygens, and there is 1 carbon. On the product side, you'll notice there is 1 iron, there are 2 oxygens, and 1 carbon. I'm going to go ahead and leave iron alone for now. I think you'll find out in the end it really doesn't matter in this instance, but once again, whenever I have something by itself, I tend to leave it. Okay, so let's look at the oxygen. I have 4 and I have 2. One of the things that, or a tip that I can give you, a lot of times you'll think, oh, the common factor is going to be 4. But if the 4 are separated, and what I mean is you have like 3 and 1, so they're not 4 together, a lot of times the common factor is going to be 6. Another similar tip, if you have like a 2 and 3 split and the 3 aren't together, we have like a 2 and a 1, instead of 4 being the common factor, instead of 6 being the common factor, a lot of times it's 4. So anyhow, back to what I was just stating, so we have 2 and we have 4, but the 4 are separated. 6 is very often going to be the coefficient that works. If I place a 3 here, this becomes 3, and the oxygen becomes 6. How am I going to get 6 over here? If I place a 3 in front of the carbon monoxide, carbon becomes 3, and oxygen, I have 3 and 3, which is now 6. Okay, so that's fixed. Now all we have is 2 irons and 1 iron. That's easy enough. Put a 2 here. Balance. 2 iron, 6 oxygen, 3 carbon. Number 12. Again. Alright, atom inventory. 1 potassium, 1 magnesium, 2 bromines. Let's look over here on the product side. We have 1 potassium, 1 magnesium, and we have 1 bromine. Well, the only thing we can start with, put a 2 here, potassium becomes 2, bromine is now 2, 2 in front of the potassium. Balanced. And number 12, let's see, we have 1 sodium, we have 1 chlorine, we have 2 fluorines. Products, 1 sodium, 2 chlorines, and 1 fluorine. Alright, if I put a 2 in front of here, sodium becomes 2, chlorine becomes 2. I need to put a 2 in front of the sodium fluoride. This becomes sodium's a 2, fluorine's a 2, 2 of everything. In this problem, we have a combustion of, really it's an organic molecule, that's propane, C3H8. Like if you have a gas grill at home, that's the stuff that's in it, that little tank. So propane and oxygen yields carbon dioxide and water. Let's see, atom inventory. There are 3 carbons, there are 8 hydrogens, there are 2 oxygens. Okay, and over here there is 1 carbon, 2 hydrogens, 3 oxygens. Okay, I'm going to start by putting a 3 in front of the carbon dioxide. That's going to change the carbons to 3. Oxygen, now I have 2 times 3, which is 6 plus 1, 7. Okay, hydrogens, I have 8 and I have 2. So if I put a 4 here, this becomes 8. And now oxygen, I have 2 times 3, which is 6, plus 4 times 1, so that is a total of 10. We can easily get 10 oxygen with a coefficient of 5. 3 carbons, 8 hydrogen, 10 oxygen. And finally, number 12. Let's look here. So we have lead 2 nitrate. There's 1 lead. There are 2 nitrogens. There are 6 oxygens present. And you have sodium iodide, 1 sodium, 1 iodine. On the product side, let's see, there is 1 lead, nitrogen, there is 1 oxygen, looks like we have 3, sodium, there is 1, and there are 2 iodines. Alright, let's see, 2 nitrogens we need over here, let's put a 2. That's going to make my sodiums 2, my nitrogen becomes 2, my oxygen becomes 6. Alright, so we fixed oxygen. Sodium I have 1 and I have 2, so if I put a 2 over here, 2 sodiums, 2 iodines, 1 lead, 1 nitrogen, 6 oxygen, 2 sodiums, 1 iodine. Balanced.